Okay, number 5. Use exponential growth and decay for the following. So we'll give you the 3 different formulas on the test. They'll be written on the board. You'll just need to know which one you need to use for which by reading the problem. So it says $600 is invested in a money market that earns 2% interest annually. How much money will be in the account after 8 years and 10 years? So we have 2 separate problems here. So we're going to take $600. We're increasing, we're increasing, so we're going to do 1 plus. 2% is 0.02 annually, so we don't have to really divide by anything since it's just annually. And we're going to go for 8 years. So that'll be our first equation. Second equation will look the same. The only difference is that 8 is going to be replaced by a 10. So I'll go to my calculator, 600, 1 plus 0.02 up to the 8. So remember, this is money. So you want to make sure we label it as money. And it's, okay, let's see here. It says 995. So really, if I rounded this, it's going to round to $703 exactly. Okay. Here we do 600, 1 plus 0.02 up to the 10. And this one would be $731. And let's look at this one. You see how it's 396. So we're going to round this up to 40 cents. All right, turn into number 6. What if the interest is compounded quarterly? How much will be in the account after 8 and 10 years? So we're still going to use the $600 and the 2% interest. So $600, still doing 2% interest, but remember quarterly means, sorry, you can't even see this, sorry. 600, 1 plus 0.02, quarterly means 4, so we're going to divide by 4. And then whatever you divide by, that's what you're timesing by, and our first one is 8 years. So we're going to do an 8 up here. And then our second equation would be the same, 600, 1 plus 0.02 over 4. And then this time we're going to take the 4 times 10 years. So 600, parenthesis, 1 plus 0.02 divided by 4 up to the 4 times 8. So we have $703.83. Change that 8 to a 10 this time, and I have $732.48. Okay, what if the interest is compounded monthly? So now we're doing monthly. Monthly is 12 months in a year. So we're still going to have that 600.02, but I'm going to divide by 12 this time. Take that 12 and times it by that 8. Same thing on the second one, except I'm going to take that 12 and times it by 10. So I got 12 up to the 12 times 8. So I have $704.01. Same thing, but I'm going to replace that 8 years with 10 years. $732.72. Okay, moving on. Assume continuous growth. So now we're doing continuous. Remember that formula is principal to the E up to the RT. That's the formula we're going to use here. So a $25,000 car depreciates. That's telling you it's going negative, 9% every year. When will it be worth less than $5? So this is one that you work backwards on. So we're going to go to y equals in our calculator, and we're going to type in 25,000 E, and then we're up to 9%, 0.09, but since it's depreciating, I need to make this a negative 0.09, and then there's my x that I'm trying to find. Okay, go to y equals. I'm going to type in, if y'all can see this, 25,000, bring up my E, up to the negative 0.09, it is 9%, right? Yeah, times x. And then I'm going to go to my table, and I want to know when is my car worth less than $5,000. Well, I need to scroll way up, because I'm still, see, I'm in the hundreds, 200s right now, so I need to go back to the thousands. And usually it will fall between two intervals. So see here at year 17, I'm 5,400, and then I go to 4,900. So between 17 and 18 years, my car will be worth $5,000, depending on this depreciation rate. Okay. Population close is increasing 3% a year. If there's currently 10,000, so there's my starting value, I'm increasing 0.03. How many koalas will there be in March of 2020? Okay. So does it tell you what year it started with? No. So we're assuming we're starting with this year. So if we're starting with this year, 2019 to 2020, so that's just going to be, we're just going to go up to the one more year. So 10,000, second E, up to the 0.03 times 1, 10,304, and it's 54, but let's think, can we have a koala that's a 0.54? No, so I'm going to round this and make sure I label. Last one, number 10, because we're skipping 11. If you've forgotten, you're skipping 11. Okay, Rest of Hill's population is currently 28,000. Assume we're growing at a rate of 0.20 each year. How long will it take Restville to be 50,000? So there's your X. You're going to put it in Y equals in the calculator. So Y equals 28,000. Second E. Oh, I need to clear this out from last time. We're growing 0.02 to the X. Second table, looking for 50,000. So I'm at 49,000, then I jump to 50. So between 28 and 29 years.